Hey guys, this is Mr. Sal. Just to get Module 6 started, we're going to look at some properties of exponents, which is, all these properties are things we really expect you guys to know already. So thanks for watching. Don't forget to like, comment, and subscribe. In general, though, these are all of the rules. Expanded power rule, negative exponents, product rule, quotient rule. I may not quote them by name because it's hard for me to memorize all those, which is good because then I don't really expect you guys to memorize the names of them. Just the properties themselves is all we really expect you to know. So here's a couple that they want us to simplify, and this first one is already too big. 14, y to the 14th and y to the 16th. I wouldn't want to expand those just because there's so many of them. So I'm just going to use the rule, the product rule on this one, 14 plus 16. So that's y to the 30th. There we go. This other one we can expand though, right? 3 to the 3rd, and this is multiplied by 3 squared. Oh, that's a 3. Decent recovery. Alright, well, we have a base of 3, and how many 3's do we have? 5. 3 to the 5th, done. I guess I should mention that the base is the number or the value that's being multiplied by itself many times. In this case, 3. In this one, it's y, and then the exponent itself is the power, or the exponent. So the exponent is just how many times you're multiplying it by itself. Now we got this quotient rule stuff. So this one here, we got a base of v, and since we're dividing the same bases here, we get to subtract the exponents, so it's k minus s. And on this other one, we got a base of 2. This one we'll actually do the math because it's not variables. It's always the numerator one minus the denominator exponent, so 8 minus 2, which is 2 to the 6th power. 64 also works. Right now I'm really just wanting to see that you guys can use the rules. But, if you want to write it as 64, that's fine too. Okay, this is, I would say it's the power of a power rule. Some people just call it the power rule, which is what that slide said. It's v to the 5th four times, right? So I got v to the 5th, but we got 4 of them. And if we were to, this is expanded, right? We're not going to expand all those 5's because there's so many of them. But if we use the product rule on this, then it's 5 plus 5 plus 5 plus 5, which is really the same as 4 groups of 5, whatever. It's the same as v to the 20th. Okay, so that's why we're able to just multiply these exponents like that, which means we can do the same for the base 3. So there's really 3 to the power of 4 times 3. It's helpful if we can just remember what exponents actually represent to do these. 3 to the power of 12, it's a pretty big number. I'm not concerned with that though. That's good. Alright, now that we got the 0 exponent rule. It's the power of 0. Usually when we see something like that, what did we see on that slide? A to the power of 0 is 1. Well, a can be anything right there, right? So, you could have maybe some kind of binomial, maybe even some x values in there, maybe some, I don't know. You guys like this stuff, right? More polynomials. Yeah, you guys liked it, right? That's just some funky stuff, but if it's all to the power of 0, it doesn't matter what the heck is inside here. It's just going to be equal to 1. So since this power of 0 includes all of that stuff, it's just 1. So if we go back, just kind of what the power of 0 is, right? If we looked at subtraction of exponents, we'll use 3. 3 to the power of 4 And if I divided this by 3 to the power of 4, if I use the quotient rule, I would get 3 to the power of 4 minus 4, which is 3 to the power of 0. Now, again, I'm using 3. It wouldn't matter what that base value was. In reality, we're just looking at anything times itself right here, right? I'm sorry, anything divided by itself, which is 1. That's why anything to the power of 0 is 1. All right, now we're looking at that, what do they call it, expanded power rule stuff, which indicates that the power is shared by all of the, I guess in this case you'd say the base values. Let's look at y though, just on this example. So I got 7x squared divided by 4, but this shows that we should have 5 of them, right? All right, now this is all multiplication, and if we remember fractional multiplication, we don't really need these in parentheses. In fact, we can rearrange them so that we got the 5 7s next to each other and the 5x squareds next to each other. All over the 4s, there's 5 of those as well. Well, what does this actually do? Well, we got 7. How many of them? 5. We got x squareds. How many of those? 5. How many 4s do we have? 5 of them. So we see that the 5 really just got distributed into the parentheses, into those exponents. We just need to remember that the 7 and the 4 had exponents of 1 in that case. And if we were to fully simplify this, I got 7 to the 5th. It's going to be a pretty big number over 4 to the 5th. And now that x squared, that's 2 times 5, which is 10. So I'm all right with that. All right, negative exponents. The problem with expressions like this is we look at the 7 as though it had a power of negative 16, but the power of 7 right there is 1. So I'm going to split this up, which is going to make it more confusing, but hopefully in the end it will help us understand what the heck is going on. This is really 7 times w to the power of negative 16, right? We got 7 to the power of 1. Negative exponents just tell us to reciprocate that value, and in this case we can say that it's w to the power of negative 16 over 1, which then allows us to reciprocate that fraction. And then it becomes 1 over w to the power of 16 times 7, right? Well, it's 7 over 1. So multiplying the numerators, we get 7. And multiplying the denominators, we get w to the power of 16. Right? So in reality, we could have just flipped the w and made that 7 over w to the power of 16. Either way you look at it, it still works, but in reality, this is kind of what's going on right there in that second line. All right, once again, we have that negative exponent. So inside this parentheses, we'll just reciprocate everything inside because this negative exponent applies to the full parentheses. So we'll just reciprocate that stuff, okay? And then it becomes a positive exponent right there. All right, well, now that we got that, we'll distribute the 3 into the exponents. So 3 to the power of 3, and x to the power of 5 times 3. 3 to the power of 3, that's not too bad. I got that one. 27, and then x to the power of 15. That looks good. All right, same idea. Let's identify this missing exponent for the 2 base. And it has an exponent of 1. So I'm going to distribute the 3 into this parentheses into the exponents, right? Distribution is multiplication. So this just shows, I mean, I don't even think everyone would need this step, but it's just showing all the work that we are distributing that 3 into the exponents. So we got the 2 to the power of 1 times 3 is 3. A to the power of 6 times 3 is 18. All over b to the power of 3 times 3 is 9. Times c to the power of 9 times 3, 27. And yeah, you can do 2 to the power of 3. That's going to give you 8 if you want. All right, let's simplify this. I recommend looking at these like terms. Now, usually when we talk about like terms, we're looking at addition and subtraction, but for a fraction like this, it's still okay. I'm going to separate this into separate parts. So I got my numbers 6 over 32 times my x's, x to the power of 18 over x to the power of 8, times my y values, y to the power of 14, divided by y to the power of 7. So this hopefully helps us to visualize which parts we should focus on. And it does help us to split this up into separate smaller problems. And 6 and 32, these are both even, so they should be simplifiable by dividing by 2, which gives us 3/16. That's good. But then we got the x's, right? That's the quotient rule, so x to the power of 18 minus 8. And then the y's, same quotient rule, right? 14 minus 7. So that gives us 3/16, x to the power of 10, y to the power of 7. And it is possible you could write this all in the numerator with our 16 denominator. I really don't care which way you write it. It is possible the homework would want that second way, but both of these are good to me. All right, with multiplication, it's kind of like the division stuff. We're just going to rearrange this, right, because these parentheses aren't really helpful to us because it's just multiplication right here. And it's really multiplication between all of these. What that means is we don't need those things in parentheses. The only reason I show that is because it allows us now to use the commutative property of multiplication. So I'm going to start with my numbers on the far left. So I got 5 times 4. Then I can move to my x's times x to the power of 9 times x squared times my y's, y to the power of 10 and y to the power of 6. And we got our z's, well, just one set of z's, 5 of them. And 5 times 4 is 20. And I've got my base x, and so we'll do 9 plus 2, which is 11. Then I got my base y's, so I'm going to add those exponents, 10 plus 6, 16. There was no other z's to combine with that z to the power of 5, so that's it. Okay, still a multiplication problem here, except for we have that exponent, the power of 4. And just by the order of operations, we should probably take care of that first. All right. So what that means is, let's just see those missing exponents. Powers of 1. And then let's distribute the 4 into the parentheses, the exponents, so that we can do the order of operations properly in this case. And we're going to take this, right, and we're going to multiply it by that other set of parentheses. All right, and this gives us one fraction, really, which is kind of what we want, just like we did with the polynomials. And you may be concerned about that x to the power of -2, but from the quotient rule, it's not really going to affect anything as long as you remember it's that you're minus a negative right there. But before we do that, let's rearrange this so that all the like values are above each other and below. All right. So this is what we got now, and again, we're just doing this so that we can focus on each one individually, which means we're going to break this up into separate multiplication problems. All right, well, working with the 2's, that's going to be 2 to the power of 4 minus 3. 5 will be 5 to the power of 2 minus 4. Our x's, that's going to be 12 minus -2. And yeah, we do need to show that minus negative stuff. Well, then we got the y's, y to the power of 4 minus 24. So we end up with 2 to the power of 1, 5 to the power of -2, x to the power of 14, and y to the power of -20. In general, we don't want the negative exponents, so I'm going to reciprocate each one of those. So let's do the 5's first. I'm going to reciprocate the 5's. Now it's 5 squared, so the exponent became positive. And I'm going to reciprocate my y to the power of -20 to be in the denominator. I'm actually okay leaving it like this. I mean, some of you guys want to change that 5 squared into 25, and that's okay too. But in general, this is the way we want to see it right here. All right. Again, we're looking at lots of different letters here. Maybe that's a little confusing for us, but if we can just split this up into separate problems or smaller separate problems, then hopefully it helps us out. So I'm going to separate the m's, y's, and r's, into their own fractions, right? All right, now we can move into the rules for these, the quotient rules. So m, I got -6 minus 4. For the y's, I got 7 minus that -8. Then the r's, I got 1 minus 9. And again, any negative exponents that show up, we're going to just reciprocate out of those. So I got m to the power of -10, y to the power of positive 15, r to the power of -8. And this will give us, by reciprocation, again, I'm just going to reciprocate the negative exponent, I guess factors, m to the power of 10, and now we got r to the power of 8. And those are positive now, so...
How did you get y to the 15?
There's two different ways you could do this one. Well, three kind of. But, I don't know. I guess, for example, some of you would want to distribute that -2 into the parentheses. Now, since we've seen that already, or some of you would even want to reciprocate that fraction to make the power of -2 positive 2, which would be okay. Just by staying with the order of operations, though, I'm going to get, or work inside the parentheses first with those r's right there, right? So the r's really become r to the power of 5 minus 2, which would be r cubed. Now that's just to simplify this just a little bit, right? I mean, it didn't do much, which is why it may or may not matter to you. And again, the order of this really isn't going to change the answer anyways. Now that we have that simplified a little bit, I am going to change that -2 into a positive 2 exponent by reciprocating the fraction. And now I'll distribute the 2 into the parentheses. That's 5 to the power of 1. And so we got z to the power of 2 times 2 is 4, over 5 to the power of 1 times 2 is 2, r to the power of 3 times 2 is 6, and yeah, 5 squared is 25.